Okay. Can you guys hear me? Sorry, can you guys hear me? Okay. 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 I'm really,
Yes,
really
yes, we
sorry.
can hear you.
Today has been very, I don't know, my schedule clashed a lot. So a lot of things not really go as planned and expected today. So I have to apologize for that. I am really, really, really sorry. I'm really, really, really sorry. Okay, so let's quickly look at our curriculum. Let me try to open it and um, mm, mm, I don't know why this system is acting very slow today. Okay, so I'll get it to class, and I don't know um of the embedded. I really hope that everybody was able to catch up. I hope everybody was able to catch up because I kept shouting it throughout last week that please make sure that you catch up so that by the time we continue today, we know that everybody is already caught up to speed. Okay, so um, in our last class, we stopped at the Arduino IDE. We've covered the first class, we spoke about resistance, voltage, current. In the second class, we covered the Arduino board and the Arduino IDE. Again, I'm really hoping that everybody went through the recordings before we have this class so that I know that when I'm making references to some certain things, we are all on the same page. Please tell me that you did. If you didn't, please let me know. Just confess now. Did we all watch the recordings? Are we all caught up to speed? Are we here? Samuel, Israel, are you here? Can you hear me? Did you watch the recordings? Are you caught up to speed? That's what I'm asking.
Yes, so I missed the
I
I
actually
started
can't
watching the
hear
recording.
you. Or is it
Sorry,
just me?
let me try. Can you hear me now?
I do know
Can
that I
you hear
can hear.
me?
Hold on.
Can you hear me? Can you hear me?
Yeah, me.
I am not up to speed. I'm not up to speed.
Where did you stop?
I'm not up to speed.
Hmm? I'm asking where you stopped. Samuel, you said you're not up to speed. I'm asking where you stopped. You watched the first recap because I missed the first class. You were there for the second class, right? Israel.
I joined the second class late for watching the recap also. I think I got to the 15th minute, but I joined the class late, so I don't really think I'm missing much. I joined the class like around 6. Yes, I don't think I'm
That
missing
day.
much at all.
So essentially,
Yes.
the first half of the second class, you did not watch it. Okay. I'll just
Yeah.
tell you to go back. Samuel, please, where did you stop? Samuel, where did you stop? Please answer me so that we can move on. We've not finished the first class. You didn't attend the second class and you didn't watch the recordings. Shall not say anything, but all I will just say is that please make sure that you finish it before the next class because we're already 1 week behind. We are 1 week behind, and the implication is that the time that I was supposed to start computer aided design, we are not going to start it. So I have to tell the person that, oh, we are going to shift it by 1 week. And I'm not even sure if we're even going to be able to finish everything. I'm not even sure if we're even going to be able to finish everything for this curriculum before we eventually have to. That's why I'm trying to move at the speed of light. But some of us don't want to. I won't say anything. All I'll just say is that please, I'm begging in the name of Almighty God, please catch up before the next class. And the next class is tomorrow. I don't know how you want to do it, but please catch up. And if for any reason you are not able to, let me know so that I'll know what I can do. Ah, sure, no problem. Card computer aided design starts probably on the 14th of February. Ah, that's supposed to be Valentine's Day. That's for the people that have. Anyway, so we discussed the Arduino board, we discussed the Arduino IDE. We did introductions. Okay, so we've not done. We're supposed to do introductions to Arduino programming now. Then we'll cover for loops, while loops, and all of that. Okay, so for this part, I will try to run through this thing. Aside from watching the recordings now, please, did you guys download the softwares that you were supposed to download? The Arduino IDE. I don't know if I mentioned VS Code. VS Code should also be there. The Arduino IDE, Fusion, SolidWorks for CAD, but that can be next month. Did you download the Arduino IDE? So that at least when I'm showing the different parts, I will take that as a no.
I have and Tinker cards. Maybe when I was
Okay.
playing I used the website
What?
and I also have VS.
Sorry, I didn't hear the last part.
I said I have the Arduino IDE And for
Okay.
Tinkercad, I use the websites as we were using the websites on the first video, and I'm still using the websites, and I have VS Code.
Okay. Okay. That's fine then. Okay. I don't. I honestly, yeah, I'll just for everything. I'll just share my screen. For everything, I'll just share my screen so that everybody will be on the same page. No problem. No problem. I don't know. Will we be able to finish this thing in 1 month? Or we have to be doing extra classes? Because I know that you guys are going to start exams soon. Samuel, have you started exams? Are you starting exams? Have you started exams? Are you starting exams? Samuel, are you here? Anyhow, I shall know that our people are starting exams soon. I think Monday. You guys are starting exams. So that probability of even having extra classes, I don't even think it's going to fly. I don't even think it's going to fly. And I don't know how we are going to. I think what we'll do is that since you guys are starting exams, Okay. Samuel is also in Abuachi.
Yes, yes, yes,
Is
yes.
he? Oh, so all of us. Oh, I'm sorry. So all of you, not me, because I can't relate again. I've graduated. So all of us. Okay. Mm, okay, so all of us. Monday. I think what I'm going to do is that from next week, we'll reduce the classes to just Saturday. Because I don't know how you guys' timetable is, but depending on how it is going to be or how the timetable is going to look like, I don't want a situation whereby you guys do not have enough time to read. You get, because at the end of the day, the academics come first, right? So I think what I'm going to do is we'll have classes on only Saturday from next week till the time that you guys finish your exams, which is probably this thing. So I don't know. Should we do it like this? That okay, we'll have classes on only Saturday. I will pre-record a class probably during the week to make up for the Sunday class that we will not have, and then we'll have class on only Saturday. Does that make sense? So that Sunday, so that the only hours you guys only need to commit like 2 hours on Saturday, or 2 hours max, 1 hour 30 minutes thereabout on Saturday, and then Sunday is free. You guys can read. You guys can do whatever it is you want to do. Is that good? Will you guys actually watch the recordings if I record it during the week? Either that or we just have our classes only on Saturday, and then we continue like that. But then that will mean that we'll not have computer aided design till like, let's say, March or so. Or we or okay, look, okay, let me mention the options. So option one is I pre-record one of the classes during the week, and then we have one class on Saturday. You guys will dedicate just 2 hours on Saturday, max, 1 hour 30 minutes on Saturday, or um, or what else again? Um, we have classes only on Saturdays till we finish the curriculum, and then we move to CAD. But then that will mean that computer aided design will be starting from March, because we have to make up time for it. Or we have classes on Saturday and then we have classes on Sunday, but Sunday's class is only for 1 hour. Which one will you people choose? Okay, so Samuel said pre-record the class, then Saturday. Who else again? Who else again? Who are the other people on this call? Okay, Augusta said to record the class. So Blessing and Israel, what do you guys think? Pre-record or which one? Israel said pre-record the class. So I think Blessing will agree. So that means
I'm actually in a noisy area, so I cannot speak now.
no problem. You can always type. You can just type in the chat box. I just type in the chat box. Okay, so since majority said pre-record the class, I'll do my best. I know what I went through last week, Sha, trying to get the recording to you people because I had leave the house very early in the morning. I come back sometimes late in the evening, and I'll cook and other things. But I'll do my best. I'll do my best. That means that I have to start from Monday. So no one, no problem. But we'll still have class tomorrow, Sha. We'll still have class tomorrow. And I'll just pre-record starting from next week. We'll still have class tomorrow. If you're able to make it, as I said, 1 hour, 30 minutes, 2 hours max. If you're able to, no problem. But just, if you can't, just text me before time. And I'm thinking we should be shifting the classes to 6 p.m. Should we be shifting it to 6 p.m.? 5 p.m. too early. Amen. Oh, amen. Thank you, Israel. Amen. It's 5 p.m. too early. 5 p.m. too early, like for our classes. Should we be shifting them to 6? So that we know that, every Saturday, Sunday, 6 p.m. Like I'm talking about after, okay. Yeah, I'm talking about after exams also. Okay, so 6. Okay, 6. No problem. No problem. So we'll be having our classes by 6 now because it's even better. So like if something happens like today we're meant to have choir rehearsal by 1. We had rehearsal by 1, then we're now meant to have a meeting with senior pastor. And the meeting lasted to like almost 4. Then we had to still rehearse after the whole meeting. So that was why I got home very late. Usually I get home before 5. Sure? No one. 6 p.m. it is. Okay, so let's move. Please, if you have not downloaded the Arduino IDE, do it before tomorrow. Do it before tomorrow. God bless you. It does not take, it's not up to 500 MB. It's not, I don't even think it's up to 300 MB to download. So please, I beg you in the name of Almighty God, download the IDE. Okay, so today, this is class 3. We are moving to Introduction to Arduino Programming. And then for loops. If you have not caught up to speed, I'm sorry, I'm not going to go back because we're already behind. So please make sure to go back to the recordings and watch them. But I'll just brush through some things. So let me share my screen now. Okay, so this is what the Arduino IDE looks like. In last class, I mentioned that IDE stands for Integrated Development Environment. Let me even see what people are saying. So when I click on this thing, it doesn't even show. Can you imagine? Sure. I explained what all these tabs are: the File tab, Edit, Sketch, Tools, Help. Like, I don't know, it's not showing on the screen that you people are seeing right now. But if you should have the idea and you click on them, you see some different things like showing as you click on them, as you hover over them. So this is the Arduino IDE. It is the software that you use to program and send code to the Arduino, depending on whatever project you are using. So in the last class, I explained all of this: the File tab, Edit tab, Sketch, blah, blah, blah. I'm not going to go over it again, I'm sorry. So void setup, as I mentioned, is the part of the code that acts as like the calibrator of the code. So I use this analogy that imagine you are turning on your generator, right? You're turning on your generator. Your generator will you are starting you are pouring in the fuel, you are turning on the gen, you are doing everything that you're supposed to do, you're on the fuel pump so that this thing will actually not just be holding the fuel, but the fuel is actually powering the generator, right? This is what this voice setup is. You are setting up everything that is necessary for the code to work, or necessary for the generator to supply electricity to your house. Then the void loop now is now the part of the generator that, okay, you've set up everything. Now let the generator start supplying electricity to the house. For you to do that, you need to turn on the changeover, Abi. And then the changeover will stay like that till you eventually turn off the gen and then change it back to AEDC or NEPA or whatever. And it goes on for as long as maybe you, as I said, turn off the gen and you switch the changeover, or in this case till you unplug the Arduino. You do not want the board to work again, or you don't want the board to you don't want the project to work again. Just unplug it or just remove the power supply. Yeah, so this voice setup is for calibration. Is a part of the code that runs only once. Calibrate it once, set it up, and it runs once. Void loop, as the name loop says, it is the part of the code that runs over and over and over till eventually you're tired and you now say, you know what, I have tried. I've done my best. I've done my best and the project has done what it's supposed to do. Okay. So introduction to Arduino programming. So for this now, if I want to do an introductory course, I'll have to go into basics of C++, more or less, because Arduino uses C. Yeah, Arduino uses C++ programming language. So I have to explain variables. I have to explain loops. I have to explain different characteristics of the things that essentially make up the syntax of the code. So I'll list a few and then I'll explain what they are. So first and foremost, we'll start with integer. Then we'll go to character. Then we'll go to what else again? String. Then we'll go to float. Then we'll go to Boolean. Which other one again is it? I think these are the 5 major ones, right? Yeah, I think these are the 5 major ones. Okay, so what are variables? Variables are essentially different parts of the code that name the characteristics that a certain variables are the parts of code that describe the states of they are the part of code that describe the state of whatever word, number, letter, characteristics. Basically, essentially, it describes the characteristics that each part of code, whether it's a word, whether it's a number, whether it's a letter, whatever, it basically gives it its characteristics. So I'm sorry, I'm not very good with English. So I will try to, yeah. A variable is any characteristics, number, or quality that can be measured or counted according to Google. Yeah, it can also be called a data item. Yeah, so as I was saying, basically it gives characteristics to the different words, letters, numbers, whatever that you are using in your code. So examples now that we have are the things that I've listed in front of you. We have integers, we have characters, we have strings, we have floats, and we have booleans. What are integers? Integers are whole numbers that we know 0, 1, 2, 3, 4, 5, 6 to infinity. I don't think infinity is a number. Anything, so whatever is before infinity, that is an integer. Even negative numbers also. As long as they are whole numbers, whether positive, whether negative, whether zero, they are integers. So far as they do not have point something, they are integers. Now, what is a character? A character is essentially a letter. Is a letter A, B, C, D, E, F, G, H, I, J. So we write it as char, short for character. So A, B, C, D, E, F, G, blah, 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 blah. Those are characters. Then string. Okay, those are characters, and they are defined inside this single quotation marks. That's how they are described. That's how they are defined. They are defined inside this single quotation marks. Then strings. Now strings are words. Strings are words. It can be one word, it can be a few words, it can be a sentence, as long as it is inside this double quotation marks. Like now, let's say everybody that is in this class: Princess, Israel, Blessing, Samuel, who else is in the class? Okay, Ogosa too. Ogosa. All this, as long as it is inside this double quotation marks, right? They are strings. They are strings. So that's what a string is. Can be a word or a group of words or a sentence. As long as it's inside double quotation mark, it is automatically known as a string. And it should be words, not just a single letter like ABC, like in character. Now, what is a float? Floats are decimal numbers. There are examples of them can be 0.00, examples can be 0.97, 0.97897 past 1, 45.2, 3.4176222, 88.9. Decimal numbers, that's what floats are. Then booleans is basically a state of essentially that they define or describe a state of being, whether something is true or whether it is false. So they can exist in only two forms. So according to Google, sorry, I'm going to use Google a lot because I'm not very good with words. So I like to at least be able to explain it in a way that you guys can understand. So booleans is a way of denoting a system of algebraic notation used to represent. Essentially, they are just showing states of propositions, showing whether something is true or whether something is false in computing and in electronics. So they only have two states: true, which is 1, and false, which is 0. So like in digital signals, now that I told you guys before that computers work using only zeros and ones, right? And I said 0 is off, 1 is on. So in this case now for Boolean has only true and false. False can be known as 0, true can be known as 1. So for Boolean, you can write the output either as true or false, essentially. Yeah, and as if you can see it properly, you can see that they are light blue, more or less. So yeah, those are the types of variables that we have. Those are types of variables that we have. Okay, so what else? What else do I have to tell you people? I think as we go, you will get the hang of it. I think as we go, you will get the hang of it. So I can only explain so much without having to go into the practical aspect. So let's go into practical. Okay, before we go into practical, let me explain some other things. So in the last class, for those of us who were around in the last class and those of us who watched the recordings, I made mention of a few things. And how a simple Arduino code usually goes. So this is what I'm going to do. I'm going to show us the easiest Arduino code that we can find, and that's like the hello world of Arduino. but in this case, it's not hello world, it's now LED blink. So why can't this thing show? So I'll just repeat. So how I was able to get this code was that I clicked on files. If you click on files, you see examples. Under examples, you see basics. Under basics, you see blink. So you click on blink. Well, you can't see it right now because I don't know, Google doesn't support you to be able to see it. So sorry. But if you have your ID, you should be able to see it. You should be able to see it. So this is the code. This is simplest code. In if we learn proper C++ or Python or any programming language, you know, hello world is the simplest. In Arduino world, as I said before, we have LED blink, which is essentially the hello world of Arduino. Yeah, so this is how we're going to do it. I'm going to make a few modifications. I'm going to make a few modifications to this code because this is not how I want it to be. So now I explained this thing. When I explained the parts of Arduino in the last class, I mentioned that the Arduino has an inbuilt LED pin and an inbuilt LED, and that LED is connected to pin number 13. That LED is connected to pin number 13. Let me just show you guys simple Arduino code. Somebody raise your hand. Sorry, I missed the point where you got to the existing code. Oh, okay. I said go to the Files tab on your IDE. Right? Under the Files tab, click on Files, go to Examples. If you hover over Examples, you see Basics. Hover over Basics, you see Blink. Click on Blink, then you see the code. Did you get it? Okay. Okay. So, LED blink, LED blink. Okay. So I'm going to show you guys on Tinkercad because I can't show you guys in real time yet. So I don't know, it's just easier to show it on the software. Just easier. Okay. So let me show you guys this part. Present something else. Okay. So this is the Arduino, right? This is the Arduino. And I mentioned in the last class, I mentioned different parts of the Arduino. Digital pins, analog pins, power pins, blah, 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 microprocessor, controller, everything. And I mentioned that the Arduino has a few passive components, capacitors, oscillators, blah, 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 and some LEDs. I mentioned that this LED transmitter and receiver. Transmitter LED to show that it is transmitting data, receiver LED to show that it's receiving data from the laptop or from whatever components, whatever is sending data to it. So this is a default on LED to show that the Arduino is on, essentially. And then this LED here is the inbuilt LED that will show that, oh, the Arduino is actually working. If it's not blinking or if it's not on, just know that in most cases, if it's not on, there are some that they don't blink. There are some that, okay, yeah, if it's not on, just know that your Arduino is burnt, your Arduino is dead. Okay, it is finished. So this LED now is the inbuilt LED that will show that your Arduino is working. And it is connected to this pin number 13. To this pin number 13 here. It's connected to that. So It's connected to pin number 13. Connected to pin number 13. So, sorry, lost my train of thought. So you can program this using this number 13 for this to blink, or you can connect it to an actual LED, connect it to number 13 or any other pin, and it will blink also. So for this part, since we're working with LED blink, right, I'm going to show us how we can be able to program it and it will work. So I'm not going to use the IDE again, sure. I'm going to use the IDE for now. I will do it when I'm explaining the other parts, but if you're using your IDE, no problem. So in this Tinkercad simulation software, I don't know why I like showing me this part, because this part is looking like Scratch, which is for babies. So I'm going to use text. Yeah. So this is the code. This is the code part. For those of you that are using Tinkercad, go to tinkercad.com, log in, and log in and then create circuit. Click on create, then go to create circuit. Then go to create circuit. For those of you that are using the simulation software, and please, if I'm too fast, just call my attention. Just unmute your mic and call my attention so that I'll know that I'm too fast and I should slow down. Okay, I think we're caught up to speed. Okay, I think we're caught up to speed. Okay, so if you're on using the software, if you're using the IDE, if you're using the software or if you're using the IDE, just follow along to what I'm doing. So we'll start at the part before the void setup. I like to do this. There's another way to do it, but I like to do this so that I declare the variable at the beginning of the code, so that if at any point I want to change it inside the code, I don't need to, because I only need to change it at one place, not at every other place. So now let me explain what I'm trying to say. So now we can see LED built-in, LED built-in, LED built-in in 3 places, right? There's an easier way. If I want to make any correction, let's say, okay, I now want to change it and use another pin, not the built-in LED. I want to use another pin, right? I want to use another pin. I can declare this LED built-in before the void setup, and then assign it to whatever pin I want to use. In this case, it's pin number 13 because that's the built-in LED that we want to use. I'll use pin number 13. I'll assign it, and let me explain what I mean by assign. So number 13 is an integer. All digital pins, their numbers are integers. 1, 2, 0, 1, 2. I mentioned you don't use 0 and 1, just start from 2. From 2 to 13, 2, 3, 4, 5, 6. All of them integers. So what I'm going to do is I'm going to write int, but I don't want to call it LED built-in, I'll just call it LED pin. Int LED pin equals number 13, semicolon, because this is C++. There are different ways for you to write your variables, Sha. You can use all small letters, you can use small letter at the beginning, capital letter here. You can use space as per underscore for space, or you can just do it the way I do it, or just use all caps. Anyway, whichever one works for you. Whichever one works for you. So I'll write LED pin equals number 13, right? So I don't want this LED built-in. I can write LED built-in here, but I don't want LED built-in. I want to make it my own. So now I write LED pin here, write LED pin here. I'm gonna write LED pin here too. Yee. All right, LED pin here. And now, at any point in time, okay, I want to change the pin for the LED that I'm using. I don't need to go here, here, here again. I can just come here and say, okay, I don't want to use 13 again. I want to use 8. I don't want to use 8. I want to use 5. I don't want to use 5. I want to use 7. I can just change it at only one point to save myself stress. In this case now, I want to use in this case, I want to use number 13 because I want this LED to blink. I'm not working with any LED, just this one on the board. So I'm going to use number 13. So in the void setup, as I said, void setup is calibration. And now for me to be able to tell this IDE that please, this is the pin I'm working with, or this is what I'm working with. Please activate it. How I'll activate it is that I will now say pin mode, meaning pin mode as per the mode of the pin. Activate this pin mode. If you're using the ID, you see that it will turn orange. Let me even show you how it is on the ID itself. You see that it is orange on the ID. Can see that it's orange on the ID. So it's a function. And yeah, it's a function. You can see pin mode, LED pin, outputs. Meaning activate LED pin, and the LED pin, since it's giving out light information, that's light. It is an output device. Then in the void loop, I will now say, okay, I want this. As I said, the void loop is the part of the code that runs over and over and over again. So I want this pin now. I want this LED to turn on and to turn off every 1 second. If I want it to be every 5 seconds, no problem. If I want it to be every 7 seconds, no problem. I can do that too. But here I want it to turn on and turn off every and every 1 second. So what did I now write? I now said, okay, digital write, because this is a digital device. In the previous class, I mentioned the difference in digital and analog devices. Digital write, because the digital device. Digital write means to send information. Send information that this LED pin should turn high, meaning this LED pin should turn on. Another way you can write it is LED pin comma 1. 1 means on, 0 means off, as I mentioned in binary language. So digital pin LED high, then delay 1000. The reason why this delay is here, delay means wait, like hold it for 1000 milliseconds. Computers count in milliseconds. They are faster than human beings, so they don't count in seconds like us. They count in milliseconds, and 1000 milliseconds is 1 second. So this 1000 that you're seeing here is basically turn on. That is basically 1 second. 1000 milliseconds, basically 1 second. So digital write LED pin low, meaning after 1 second, now turn the LED off. Then put delay again. Hold it for 1 second. That's 1000 milliseconds. Hold it. That's the delay. Wait and hold it for 1000 milliseconds. That's 1 second. So continue. Let it go on and off and on and off and on and off for 1 second. Do you get? Am I moving too fast? Okay, I'll take it that we're on the same page. I'll take it that we're on the same page. So this is it. So let me go back to Tinkercad. Yeah, so this is it. This is it. So now if I start the simulation, you can see. Yeah, sure. You can see that the LED, this inbuilt LED is blinking on and off. Yeah, so we can see that this LED is going on and off. So that is a simple Arduino code. The simplest, in fact, yes, the most basic Arduino code that we can think of. And that is the LED blink, essentially. So now let's move on. I hope you understand. Do we have any questions? So I'll take that as a no. Let me stop the simulation. Let's do something else. Let's do something different. Let's say we want to add an actual LED to this. So this is what I'm going to do. In the first class, I explained the importance of the resistor. So let's do something different. Let's actually use this one. Let's connect an actual LED to this thing. If you're on Tinkercad, just follow what I'm doing. I brought out my LED, brought out my resistor. Then I connected the positive part of the LED to the resistor and connected the other part of the LED to pin number 13. And I take the negative part and I connect it to ground, which is GND. So after doing this connection, are we together? Am I too fast? I'll take that as a no. Okay, thank you. So if I start, sorry, the code, same code that we used before, then I start the simulation. Just look. Number 13, the built-in LED connected to number 13, blinking once and twice, on and off, on and off, on and off. If I want to increase the number of seconds that it is on for, let's say I want it to be on for 7 seconds and off for 3 seconds. In total, making 10 seconds for the cycle. So all I have to do is make it 7,000 milliseconds, which is 7 seconds in human being time, and then 3,000 milliseconds, which is 3 seconds in human being time. So on for 7 seconds, off for 3 seconds. Let's go. 1, 2, 3, 4, 5, 6. You can see the simulator time here. 7. 1, 2, 3. Then on again. Then 1, 2, 3, 4, 5, 6, 7. Off. Then 1, 2, 3. Then on again. Then continues like that. Continues like that. Continues like that. Continues like that. So yeah. I hope we get it. So that's the most basic of the most basics. That's the most basics of the most basics. Okay, so moving on. Moving on. That's introduction. As I said, the simplest one. So now let's move to loops. Should we move to loops now? For loops, if else. I think loops will be very complex. Let's skip. Let's go to lesson 3. We'll come to this after we have completed this. We'll come to loops after we have completed this lesson 3. So let's go to lesson 3. Let's go to lesson 3, because loops is going to be a more complex, in-depth. Excuse me. Okay, so now we are going to be working with basic electronic components. We have a long way to go, but this is the fun part. Don't worry, this is the very, very fun part. So lesson 3. Lesson 3 is understanding and working with basic electrical components, working with the potentiometer, the RGB LED. RGB is red, blue, green LED. So basically, one LED has these 3 colors and can mix them together to produce magenta, purple, cyan, all of that. So yeah, this is the fun part. This is part I've been waiting for since. So first and foremost is the potentiometer. The potentiometer. Okay. So in the last class, I'm going to make reference to the last class a lot, but don't worry, I'm going to explain it. Again. So in our last class, I spoke about the potentiometer. I said the potentiometer is an analog device, and analog device meaning that it gives a range of values, the range of values for data that it gives is from 0 to 1023. I explained why 0 to 1023 sharp. So please go back and watch the recording if you do not. Go back and watch the recording if you've not gotten to that part. And if for any reason you are stuck, reach out to me, because that's why I'm here. Reach out to me. Just reach out to me. Okay. So yeah, potentiometer. So potentiometer is an analog device. Analog device meaning it does not need, like, how do I explain this? Analog device meaning it does not need maybe the way. Okay, let me use this analogy. This analogy I use. We have our analog watches, like wristwatches and analog clocks, and we have our digital clocks. These digital clocks work with batteries, and they work with like digital devices inside of them that allow them to essentially they are programmed with different combination of different electrical devices and all of that allow them to run. And because of how they are programmed, that's how they are not able to tell the time. That's how you will not be able to set it. That's how you're not be able to give it alarm. Sometimes we have our Apple watches and some other watches that I'm not really big on digital watches, so I'm looking for how to explain this. I can be very traditional at times. So digital watches use a combination of a lot of digital devices. They are programmed, and those set of programs are what allow them to be able to do their tasks the way they are supposed to do them. But then for analog watches now, analog clocks, they use mechanical components, not electrical. They are not programmed. They just use mechanical components, and based on how you set them, based on how they are configured or calibrated, they work with them, and then they now give you the time using the combination of gears inside of them, using the second, the minute, the hour hand. That's how you're not able to tell time on the analog watches, right? So Analog devices are like analog watches. They use mechanical components. Oh, sorry, they use electrical components, but like they are not programmed. They just use them based on okay, God. Okay, let me just go to the explanation of how a potentiometer works. When I explain it, you guys will be able to understand. I don't know why English is failing me these days. I don't know why English is failing me these days. Okay, potentiometer, blah, 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 blah. Basically, their mode of operation is more mechanical than electrical or programming. How a potentiometer works is this is it, right? This is it. This is the inside of a potentiometer. It has 3 pins. These are the 3 pins. These are the 3 pins. 1, 2, 3. I don't know if you guys can see it well. I don't know if you guys can see it well. But these are the 3 pins. These 3 pins, one is VCC, that's connected to power. One is output, that's signal connected to any analog pin, and then one is ground, connected to ground, of course. So how it works is that this output, between this, there is a resistor, an inbuilt resistor inside of it. Yeah. So this inbuilt resistor, it now has a wiper. You can see like the mechanical aspect that I'm talking about. Like it's not using electricity or programming or anything, like it's using mechanical means. So inside of it now, it has a wiper. This wiper is the knob that we turn. This knob that you're seeing here, that's the wiper. So based on how we move the knob, the wiper will move. So inside of this potentiometer, we have this resistive strip. This resistive strip can have like the total resistance on a potentiometer. If you look at the bodies of potentiometer, you'll see that on top of them there is a number. There's a number written on them. Sometimes it can be 5K, sometimes it can be 10K like this one, sometimes it can be 20K, sometimes it can be 100K, depending on however. So imagine that inside of them they now have like 2 resistors, and then based on how the wiper moves, the resistance of those resistors increase and reduce relatively. So let's take for instance now, where's my mirror board? Let me draw it. Let me draw it. Wow. Ew, start signing again. I think it was this one. Okay, so this is my mirror board. Let me draw it. Sorry guys, you guys can see my screen, right? Don't worry, we'll be done soon. I said 7:40. We'll be done very soon. Plus this thing is going to end very soon. So yeah, so imagine this is your potentiometer. Oh my god, this is horrible. This is your potentiometer. Oh no, I'll use my hand. This is your potentiometer. This is why I don't like this thing sometimes. This is your potentiometer, and this potentiometer is made up of 2 resistors. Resistor 1. Ew. What the heck? What is this? Eh? Ah. Hey. Okay. This thing just wants to frustrate me today. No problem. No harm. We shall work. This is resistor 1. Yeah. Ew. Thank God I have my mouse. This is resistor 1, continue 1, and then this is resistor 2. Please do not mind my ugly drawings. I'm trying my best. And then these are the pins 1, 2, and 3. So inside of it is a wiper. This is center, and then this is the wiper. So this wiper can be here, can be here, can be here, it can be anywhere essentially. But let's imagine in between. Let's assume this is a 10k ohms potentiometer. That 10k is for ohms. So the resistance, because there's resistance inside of it. There's resistance, there are resistors inside of it. So just use this one. Just use this one. So imagine this is the center. So if this is the center, meaning that the resistance in between these things are divided equally. So meaning if it's 10k, meaning that there's 5k ohms here. There's 5k ohms here, and there's 5k ohms here. But then imagine I now change the position of this wiper to here. And now change the position of this wiper to here. And let's say this place is 1k ohms. In using our imagination, let's say this is 1k ohms. How many ohms will not be left here? How many ohms will not be left on the other side? Nobody is answering me now. If this is a 10k ohms potentiometer, right? And if this is a 10k ohms potentiometer, and 1k ohms, the wiper stops at this right hand side. 1k ohms is on this side. How many ohms will be at the other side?
I think it will be 9.
9k, Abi?
Yes.
Very good. Thank you, Augusta. Thank you, blessing. So 9k. Hey, horrible handwriting. So 9k ohms is what will be here. So that's how a potentiometer works. It uses a wiper. The wiper is enough, and based on how the wiper moves, the resistance of one side will increase while the resistance of another side will reduce. If it was the other way around, if this was now 2k, if this was now 2k ohms, this side will now be 8k. Figuratively, using our imagination, sharp. So that's how it works. They basically use wipers based on how the wiper moves. The resistive strip, the resistance of one side will increase, the resistance of the other side will reduce. So let's see how to connect it now to the Arduino. And I'm giving you guys scope because this is what I usually use. So sometimes the potentiometer has 3 pins: the VCC, the output, which is signal, and the ground. So if you're a beginner, but sometimes like I usually get the wiring wrong for the potentiometer. So you can check, go online, check, okay, potentiometer Arduino, how do you connect it? Then I'm giving you guys scope so that, even if I'm not there, I'll be able to connect it. So since this part now, this is a 3-pin potentiometer. There are 6 pin, there's 5 pin. There are different types, but the most basic, the most common one is a 3 pins potentiometer. So if it is like this is ground. We all know that ground is connected to ground. This is output. Output is signal. And because this potentiometer is an analog device, this output is signal will be connected to any analog pin of our choice. Because it's an analog device. Then we have VCC. VCC is connected to power, either 5 volts or 3.3. And as I mentioned in the last class, you should always check the the maximum input voltage, so that whenever you're connecting them, they will not, you will connect it to the right power source and they will not blow. So now maximum input voltage for potentiometer is between 5 to 10 volts. I'll show all this. You can look at all of this and it will become intimidating. Just focus here. Power rating, blah blah blah. So essentially 5 to 10 volts. Essentially. So don't be intimidated by all the jargons that is there. So let's go to the Tinkercad simulation that we can be able to run all of this. Let's delete this, yeah, and then let's look for potentiometer. So this is potentiometer. This is the potentiometer, and we know that this part, which is will be connected to, from the diagram we saw earlier, this part will be connected to ground. Just please make sure you're following what I'm doing now. This part will be connected to ground. If I'm too fast, let me know. Part connected to ground. This part, which is signal, will be connected to any analog pin of our choice. So I'm going to connect it to A0. And I want it to be orange because I'm a color code person. And also a perfectionist. Okay, and then this is for power. So this will be connected to 5 volts as we saw in the charts. So this is red. Okay. So now let's write the code for this. Let's write the code. Let's write the code. So for this, because we are going to be sending signal or receiving signal from one part. So this is going to be connected to A0, right? So follow what I'm doing now. So this is int. We're not using LED, we're using potentiometer. Potentiometer is long, so I'm going to call it port. And port pin is connected to A0. Meaning that since we are reading from it, we are reading from it, so it's input device. Sorry, so it's in this case it's input. We are reading from it, we are receiving data from it, we are not sending data. Okay, we are sending data to people, like we are reading the data from it. So I'm going to write pin mode port pin is input. Input. Then digital write. Does this part have the serial monitor? I think. Okay, sure, does this thing have serial monitor? Jesus. I don't think it does. Okay, it has. Thank God. Okay, good, very good. Okay, very good. So we're going to wipe these parts because we want to read what is from it. So this is what we're going to do. We are going to assign a variable inside of it. Eh? And just follow what I'm doing. We'll now write int port value. Port value is equal to analog read. Read means you are getting data from it, you are reading data from it, you are not sending data to it, you are receiving data from it. So analog read. So you are reading from the potentiometer, which is an analog device. So analog read port pin, which is a naught. So you are reading from the potentiometer pin. And then I'll add a delay of like 250 so that it's not go too fast. And the kidney will not burn. Okay, so after that, we are going to do something because if we want to read from it, there is no screen on this potentiometer that will be able to tell us that okay, we want to read from so so and so. There is no screen on this thing. There's no screen on it. Oh, Israel Sash, come again with the wiper. Which part? Ah, I didn't see your message on time. I'm so sorry. Please, next time, just unmute your mic. Is Israel still here? Okay. Please, which part again? The part of the wiper. Which part didn't you understand?
9 kilo, 8 kilos.
Okay, like when it moves.
Yes, when it moves.
Okay, okay. So let me go back to my mirror board. Let me share it again. So imagine this is so ugly. Okay, imagine this thing that I drew, right? Is imagine this thing that I drew is where's this diagram? There was one diagram that displayed this thing very well. I'm coming. Let's go back. Okay, so imagine where's this diagram? So it just now. Anyhow, Sha. Oh my god, it's so tiny. Okay. Imagine it is this. Can you see my screen? Can you see my screen?
Yes, I can.
Okay. So imagine this is my wipe. This is inside the potentiometer. Yeah. This is the ground. This is the output. This is the VCC. This is now the resistive. This thing. The resistive track. The resistive track. Imagine there are two. There's like this track now, resistance measured in ohms, and every time you look at potentiometers, there's usually a number on it, and that number will now be okay, maybe 10k, 10k, 5k, 100k, whatever. That's the measure of resistance that this resistive track inside the potentiometer has. So this resistive track now has a total of 10k ohms. That's total of 10k ohms. So I was saying that with the wiper, this wiper is the knob on top of the potentiometer, the part that you can turn, and do like as if okay you're turning a knob. You get. So that's what this wiper is. That's what it does. So based on how you move the wiper along this resistive track, one part will increase in resistance, the other part will reduce in resistance. Do you understand? So if I move this track now to this side, to this right hand side, the resistance here will increase. The resistance on this side will be more, and the resistance on this side will reduce. Do you get? That was what I was explaining here. That okay, now here the wiper is now at this point. Imagine as this point now, this side, imagine is a 10k ohms potentiometer. So meaning that this side is 1k. Imagine it is 1k. And if it is now 10k ohms, how many what is the measure of resistance at the other side? If it is 10k ohms in total, and this side is 1k, what will now be left? 9k exactly. So that's it. So that's the part I was explaining. 9k. I don't know. I'm very this handwriting is annoying me. 9k ohms. But yeah, that's it essentially. So do you get, is that clear? Yeah, okay. You're welcome. Okay, so let's move. So I'm going to jump a few steps. Which simulation are we starting now? I'm going to jump a few steps because I was meant to show this is actually supposed to be in the introduction. So okay, so we're working with just the potentiometer. Working with just the potentiometer, but there's no screen on the potentiometer. So how are we going to know what measure or what data is given out? What are we going to do? We're going to work with something called the serial monitor. And the serial monitor is a part of the Arduino IDE that basically shows us what is going on inside of the components that we're working with. This is it here. In your IDE, you'll see it. Let me show you how it looks in the IDE. When you eventually download the IDE, for those of you that have it. In the IDE, this is how it's going to look. Your serial monitor will be this shortcut here, or you can come to files. Okay, no, or you can come to tools. Under tools, you'll see serial monitor, or you can just come here. The shortcut is here also. You can click serial monitor. So this serial monitor will come up like this. And it's part that will show you everything that's going on with the components. Should you activate it, it will show you everything that's going on with the components that you're working with. So let's activate it now. Let's activate so that we can see what is actually going on with the potentiometer. And you guys can see that what I meant by from 0 to 1023. So in this void setup, which is calibration part, that's why we're going to activate it. So this is the command we'll write. So we'll write serial.begin. We'll write serial.begin. 9600. 9600 is like the baud rate, like the frequency or the in other words, let me use a term you understand, like the frequency at which we want this serial monitor to work or to operate. Baud rates. It's not exactly frequency, but there are different types of baud rates. There is 4800, there is 9600, there is 115,200. There are different baud rates, sure, but basically based on how whatever one you want to use, you have to tune the serial monitor to be able to match the baud rate that you're working with. But the most standard baud rate that you use is 9600. And let me explain what is a baud rate. What is a baud rate? I have to wrap up because I have something to do by 8, I guess. I have something to do by 8. Uh, but I hope you guys have understood what I've been explaining so far. Nobody has any questions. I feel like we're actually moving so slow, and it is annoying me. It is annoying me. So, Israel, raise up your hand. You can unmute your mic. What do you want to say? Maybe it was a mistake. Okay. So baud rate is the speed of data transmission measured in bauds, BAUD, baud rate, representing the number of symbol changes or signal events like voltage shift per second. So basically, the measure of change in the numbers of the numbers used in data transmission, essentially, that's the baud rate. So the rate at which numbers change, the rate at which symbol numbers or signal events like voltage shift change per second. That's what a baud rate is, essentially. It just basically it just defines how quickly devices exchange data. That's the baud rate. So it's the rate at which devices exchange data. So, but the most basic one, not too fast, not too slow, 9,600. So I'm going to say that, okay, activate my potentiometer pin. It's an input device because I'm reading from it. I am going to initialize or activate my serial monitor using serial.begin. In my void loop, I'm going to tell the program that the port value I did not, but there's going to be an error because I did not define port value initially. Any variable or whatever that you're using in code, you have to initialize it at the beginning of the code so that it's not read an error. But let's just see what happens. So initialize the potentiometer. The port value is now the value that you get as you're reading from the port pin. Then I'll now tell it that, okay, let the serial monitor print the values that it's getting from the potentiometer. So in this case, I'm going to write serial.print. Inside brackets, I'm going to put port value because I want it to show me the port value, semicolon. So this is just going to be words in strings. Then I'll now tell it that, okay, now print serial.print ln, meaning that after every value it gives me, I want a new line to show. So I'm now going to write port value, semicolon. Make sure that the cases are always the same. If it's capital letter you use, let it be capital letter you use at every point in time. Then end. Then I'll now put a delay of 2000 and, yeah, 250 so that it will not go too fast. So we can be able to read it well. So essentially what I did is that I wrote serial.print. In the serial monitor, print port value is equal to, or semicolon, give it space. The remember is in double quotation marks. So it is a string. And because it is a string now, it's going to be in, because it's a string, it's not going to read it as an array, just read it as words. But then this serial.println port value, the values that it reads from the potentiometer pin, it will now display it here. This println means after it displays it at every point in time, I don't want it to be going in a straight line. I want it to be that after it gives me one line, it gives me the next line, it gives me the next line, it gives me the next line, like that, like that, like that, like that, like that. You understand? You understand? So now let's start this simulation. and let's see what goes on. So now on the serial monitor, you can see port value is 0, port value is 0, port value is 0. So let me shift this. Let me stop the simulation first. Let me shift this to this side. Oh my goodness. Let me shift it to this side so that when I'm actually changing the knobs, when I'm actually turning the knob, you can see it. So now you can see the port value is 0. Let me start changing it. You can see the wiper now. I'm changing the wiper, right? You guys can see it, right? So it's at 0. That's the lowest point. I'm moving it. I'm increasing it a bit. Now it's at 61. I'm moving it. Now it's at 123. I'm moving it, 240, 300 and something. I keep moving. 600 and something. Take it to the extreme end. This is the highest point. It stops at 1023. So this should prove to you that potentiometers, analog devices, have a range of values from 0 to 1023. Understood? So now wiper keeps going, it's increasing, it's reducing, it's increasing, it's reducing, it's increasing, it's reducing. Can see the values changing here, like that, like that, like that. So yeah. Okay, so are we good? Are we good? Okay. So should we, let me look at the curriculum. Maybe we'll stop here, or maybe we'll, okay, let's just do one last thing. Let's just do the RGB LED. This one won't take time. It's like using a normal LED, just that the connections are different. But it's more complex, sure, but let's just use it. Let's just use it. So this will be the last thing we'll do. Then we'll call it a day. Let's stop the simulation. Then we'll call it a day. And I'm going to give you guys assignments. Should I give you guys assignments? This one, like people have exam. Will you guys be able to do the assignments if I give you?
Yes, for me, I'm not currently writing exam, sure, yes. But I don't know about others.
Oh, okay. Others, will you be able to do the assignments if I give you? You're not sure. The assignment is not that difficult, sure. But let's just see how it goes. Let's just finish this. So we're working with the RGB LED, as I said earlier, is the part of, is like an LED, just that it has 3 colors: red, blue, and green, or red, green, and blue, hence the RGB. So we can see it here. So let's see. I usually forget the pinout, so I won't lie to you. So I'm just going to search. How do we connect it to an Arduino? I shall know that there's a resistor somewhere in this. Yeah, there's a there are resistors somewhere in this connection. Okay, so let's use this. Yeah. So 3 resistors, then okay, let's go to Tinkercad. Let's remove this. Bye bye. Let's look for the RGB LED. It should be here somewhere. Yeah, this is it. So this is the RGB LED. And this cathode, red, blue, green. Okay, let's look at the connections. So The cathode is connected to ground, because I guess that's negative part. Cathode is connected to ground. And these other parts are connected to other digital pins and they have resistors in between them. Okay, no one. Let's come here. So we need 3 resistors. Resistor 1, resistor 2, resistor 3. If I'm too fast, let me know. So this is red. Red will be connected to resistor 1. I feel like it's even too low safe. And then any digital pin of our choice. Oh God, I have so many assignments to do before tomorrow. Now they've given me working choir. No problem. Okay, then this is blue. I'm going to color code it, of course, because will it be color code? Will it be princess if there's no color code? And this is blue, my favorite color. Ah, such a pretty color. Move up, come to 9. Yeah. There's a way we can mix the colors, sha, but I'll leave that one till tomorrow. But let's just, okay, and then this is green. So of course, again, color code, this is green. Okay, and then this cathode part is connected to ground, so it's going to be black. So black. Yeah, wow. So we're going to program it somewhat exactly the same way we program the LED. But okay. So LED. So this is what we're going to do differently. We'll name this red. And red is connected to number 8. We'll do copy. Oh, sorry. Oh, shit. Mistake. Copy, paste, paste, paste. So this is blue. If I'm too fast, let me know. We don't have much time because it's almost 8. And blue is at 9. Then green. Ah, God, my head is actually thinking. Green. Then 10. Okay. So pin mode, we're going to do pin mode for all of them. Red pin is output, and LED is giving out signal or data. So red is output, blue is output, so green too is output. You get? So we don't need serial monitor. We can either do this or we can comment it out by pressing Control/. If you are using the IDE, you can just do / as a way of commenting it out. Commenting it out means hiding it from the IDE, so the IDE will not recognize that it is part of the code. So I hid it. So what I'm going to do is I am going to do digital writes. Digital writes, red pin high. And delay for 1 second. Then digital writes, red pin low, turn it off. Then I'll put delay. I'll put 1000 for 1 second. Okay, let's do this. This for red. Let's do for blue and green. Copy, paste, paste. There's going to be space in between. If I'm moving too fast, please let me know. Sorry. So this is for blue. This is for blue. And then this is for green. And this is for green. So now we've done this. We've declared the red pin, the blue pin, the green pin. We've activated them, pin mode, all of them are outputs. And then we've told it that let the red pin turn high for 1 second, then turn off. Then blue turn on for 1 second, blue turn off, then green. So like that. So let's start the simulation and let's hide the code. So red, blue, green. Oh my gosh, it's so pretty. Oh my gosh, it's so nice. Okay, so now let's do something else that is actually, did it work for you? Did it work for you? Let me know. We have 5 more minutes. Did it work for you? Or was I moving too fast? Should I give you time? Okay,
That's
okay.
right.
I'll hold on. I'll wait. Okay, let me show the code. Okay. So sorry. This is good. Visual, are we good? Okay, almost. Okay. Okay. So this is okay, sorry. This is circuit. So red has a resistor, blue has a resistor, green has a resistor, all of them connected to any digital pin. I chose 8, 9, and 10. Then the cathode, you see it's the second pin connected to ground. So basically think of it as 3 different LEDs in one combined. Okay, so it worked. Yay. That's very good. That's very good. That's very good. Okay, so um I guess we are set and we are good to go. Mm, okay, very good, very good, very, very good. Okay, Mm, all right. So that is it, and that's the code. So I wanted to do one last thing before I wanted to do one last thing before the whole ceremony, before the whole this thing. So I said that the RGB LED has three colors: red, green, and blue, right? And um, these colors, they are three in one. As I mentioned earlier, I said when you mix these three together, they will eventually give you other different colors like magenta, purple, cyan. Sometimes if you mix all of them together, it may give you white. So I want us to do a quick exercise where we mix up different colors, and then they'll give us like different we mix up different colors, two different colors, two three different colors, and then we mix the last one, and then we now get like different colors entirely. So okay, so we have this code, we have digital rights, red LED high, blah 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 blah, right? So what I'm going to do now is let's say I want to do the color purple. I want to do the color purple. So what I'm going to do is that I will mix what color gives us purple. I'll mix red and blue together. Oh, sorry, I didn't stop the simulation. I didn't stop the simulation, sorry. Okay. So I want to do the color purple. I want to make the color purple. So what am I going to do? I'm going to mix red and blue together. So what I'm going to do is that I'll do digital right, blue pin high. We'll finish this class by 8:15. And let's say I want it to turn on for at least 3 seconds. So blue pin low. So let's say that's what I want to do now. I hope we are following. I think somebody wanted to join. Right. Somebody wants to join. Now, anyway, so if I start the simulation now, let's see if it is going to give us void loop. What's the problem? Blue pin was not declared. Assign now. Digital rights, blue pin. Digital rights, blue pin. Was not declared as well. Oh, I made a typo. So Oh, let's start. Let's see. Did he do purple? Yes, he made purple. So as you can see, blue and red, mixing them together gave us purple. Try something else. Oh, Israel, should I wait? Should I wait? Should I wait? Should I wait? Okay, thank you. So red and blue. So let's say I want to mix red, blue and green. What is blue and green going to give us? What's red and green? Blue and green going to give us? Well, let's find out. Blue and green. Blue and green. Okay, let's see. Blue and green give us what? Oh, cyan! Blue and green give us cyan. Blue and green give us cyan. Okay, I love this shade of blue though. So pretty. Okay, now let's go to the next one. We've done red and green. We've done red and we've done red and we've done red and blue. We've done red and we've done green and blue. So now let's do red and green. Let's do red and green. Then the last one, we'll do all of them together. Let's do red and green. Red and green will give us yellow. Red and green give us, it's like printer colors that we use. It's like printer colors that we use for this thing. Printer colors that we use for this thing. That's so nice. Like in printers, we have magenta, we have cyan, and we have this thing. Okay, yeah, that purple was magenta. Okay. So now let's do all three. I think all three will give us white. So let's go. Now start the simulation. Yeah, I was right. All three will give us white. Yep. So we have covered two digital components, sorry, electronic components. Yay for us. Yay for us. So your assignment is, we have worked with the LED, we have worked with the potentiometer. Now I want you to work on a dimmable LED project. Dimmable LED in the sense that, okay, that have a message. Okay. Dimmable LED in the sense that the potentiometer will adjust the brightness of the LED. So whether the LED will as the LED will increase in brightness as you're turning the knob, the LED will reduce in brightness as you're turning the knob. So that is your assignment, and you can find it in the playlist that I sent you. You can find the video. The video should help you. I'm not going to tell you which video. You should look for it by yourself. The playlist is on the group chat. I'll pin it. So yeah, I hope we had fun today. Does anybody have any questions? Does anybody have any questions?
Also, Lily,
Good evening.
I want to ask, what was the real world use of this setup, of this RGB?
The real world
Can you hear
use.
me?
Yeah.
Yeah, like, yes. Like, where is it apply?
When in the first class, I think was it the second class, I made reference to a light bulb, right? And I explained the operating principles of how a light bulb works, and the reason why sometimes in electronics using an LED is more um energy energy is more, what is the word I'm looking for here? It's more beneficial if energy preservation or conservation of energy is your target. Because a lot of times when you use light bulbs will emit a lot of heat and they will use a lot of power. But when you use LEDs will help you to, they produce light using the metal film that is inside of it, and using that metal film now produces light, unlike the light bulb that uses the filament, and that filament is eventually going to cause heat. So LEDs are more, they don't consume as much energy and they do not produce as much heat, so they are more energy efficient. So when you are using LEDs, you can use them in place of light bulbs for any either prototype you're using or anything. The reason why I use this RGB LED was to increase your understanding of how LEDs work, essentially, and also increase the complexity of how you have used LEDs to practice before we had this class.
Okay, yeah. Thanks, man.
No problem. No problem. Does that answer your question? That's
Eh,
satisfactory, right?
Yes, yes, yes.
Okay. Does anybody, okay, Israel, you have a question. Israel,
Okay,
you are
so
ready
the
on.
other time where you said maybe you should wait or something, then and I said you should go on the. I actually am falling behind because it was showing you could not reach the compiler. Does that usually happen on the web? Like I couldn't
You could
compile
not
it.
read it.
What do you say?
Please share your screen. Let me see.
Oh. Um, um, can you see it? Okay, I think it's network.
Oh, okay.
Okay, thank you.
So it's working now.
No, it's not working. I think maybe like the network here is bad or something.
Oh, okay. Maybe
Because it's
try
saying
it
connection
again.
loss.
Oh,
All
sorry.
right, thank you.
Maybe try it again at a later time. If you have any issue, just reach out to me.
All right, no problem.
What paper do you have on Monday?
After the entrepreneurship.
Okay. You and what's his name? Eniola, you guys are in the same class.
No,
Sorry,
I
set.
think he's,
In the
he's doing
same
a
set.
different
In the
skill.
same set. No,
Yeah,
like in the same set.
yes.
Okay, I think I have an idea of what people have next week. Okay, no problem. No
All right,
problem. So
thank
we'll
you.
have class tomorrow by 6. Tomorrow's class won't last this long, because we're just working with buzzers tomorrow. We'll just do active and passive buzzers. They are very simple. Then we'll call it a day. Then I'll do the recording for photoresistors, push buttons, and the remaining sensors. Then yeah, I think once we get the basics, it's not very hard for us to move on to like using other sensors and electronic components and all of that. So I think the tomorrow maybe we'll talk about for loops, while loops, if and else statements, and all of that. And then understanding, we'll just do small theory at the beginning, then we'll do practical, like what we did today, and then we'll move on. All these other ones, if we know the connections, we know every other thing, it won't be hard and it won't take time. 30 minutes max, we should be done with the theory, with the practical parts. 30 minutes max, we're done with the practical parts. So yeah, I think that's all for today's class. I'll upload this so that if anybody wants to make reference to it, can make reference to it. Then we'll do it, we'll use it tomorrow. We'll use it and we'll continue like that. So I have this idea that at the first month of whatever, whether embedded systems card, whatever, I think after every month I will make, because the way I set it now, it's on our YouTube channel, but it's only the people who have the link that can access it, that can see it. And it's only you guys that have shared the link with. So I'm thinking that after the first month, we will, after the first month, I will just make it visible to everybody. But then it won't be, they can't really ask questions like that because, I mean, it would have passed and would have moved to card. Right, so I think that's what we'll just do, so that at least our page will be bulky, but they won't have the same benefit you guys have, of course. So that sounds fair, Abby. Nobody's saying anything now. Sure? No. Okay. Okay, so hopefully I'll just talk to the person that is supposed to take the card class. I also spoke to somebody, I think during summer we'll do classes on PCB design, that's printed circuit board. We'll do classes on that soon. I've already spoken to the person, I think around August time. But then that's when the mentorship program is starting. Sure, we'll see. We'll see. God will help us. We'll see. We'll see. We have a lot to do. We're meant to have the cybersecurity event next month, but I don't think we're going to have it next month again. I think we may have it in April, because after the publicity for this thing, the Gen Z Legacy Conference, I'm tired. I did not know publicity would be like this. I'm actually tired, but the Lord is my strength. The Lord is my strength. I've been multitasking a lot, and thank you guys for signing up. Please, as much as you can, help us spread the word. If you can repost the flyer, repost the flyer. Whatever you can do, please do. Help us, because it's only 30 something people that have registered so far, 38. So let's make this count. Let's make this count. Let's bring this one. I was even thinking of postponing the event, but I don't want to postpone it. I really don't want to postpone it, because one of the speakers, I think this is the only weekend that she'll be free. So let's just hope and pray to God for the best, and God will help us through. All of you writing exams, success. We'll see tomorrow by 6, and we'll finish tomorrow. Don't worry. By that I would have been at home by before 2, and I would have been home before 2. I would have rested and eaten and done everything that I need to do. So by 6, I promise, 6 on the dot, we'll start. Later 6:10, because I usually give the grace of 10 minutes for people who want to do. So later 6:10. So yeah, thank you guys so much for joining. Have a good night, and any other, I'll do my best to make sure that the recording is up on our YouTube before 12. Before 12. So yeah. Bye.
Yeah. All right, man. Good night.